Hello everyone, my name is Anthony Gahn, and in this video I will be talking about the applications of hybrid electric and pure electric propulsion systems. Listed here on this slide are four areas where electric propulsion systems have been explored or are currently in use today. In the following slides, I'll provide some examples of the use of different types of electric technology in each particular area. In doing so, I will also touch on why electric propulsion is used in each sector and why it is particularly beneficial. Finally, I will mention what the future looks like for each area and how further improvements to this method of propulsion are being investigated. There will be a nice mix of information for each section, and my goal is to showcase some of the ways that this technology is emerging in our world. The picture shown here is a solar electric concept for a mission to Mars. While this will not be touched on in the following slides, I felt that it would be cool to include as a technology that goes into this spacecraft has been extensively worked on here in Ohio at the NASA Glenn Research Center in Cleveland. The first area I'll be looking at is spacecraft. One of the particular applications that hybrid electric propulsion is used for in this area is the motion control of spacecraft that move on non-Keplerian orbits. Electric propulsion currently works in combination with the influence of complex configurations of gravitational fields in order to effectively control motion. This motion control is particularly important near systems that contain two gravitating bodies, for instance, near asteroids or between planets. Space exploration is particularly expensive and does not always give quick feedback, which paves the way for electrical propulsion as an alternative. Electric propulsion systems can provide a higher performance than traditional systems and can potentially allow for quicker feedback than we've ever had. Since these gravitational fields are so complex, there still exists a need to further optimize the methods in which electric propulsion is utilized. Using the current knowledge on planar movement of spacecraft with electric propulsion as a base, iterative methods of optimization that use mathematically specified models of movement, as well as spacecraft design shape, are being researched in order to further develop this method of space travel. The next area that has seen the use of forms of electric propulsion is satellites. The first one I will discuss is low Earth orbit station keeping. The upper layers of the atmosphere are known to have a highly dynamic environment, with its conditions changing with altitude above the Earth's ellipsoid and with time. The long-term low-thrust capabilities that are an advantage of electric propulsion systems are used to combat these dynamic conditions, and low Earth orbit spacecraft have already been designed with this technology. However, there are still issues that exist with using electric propulsion in this area. Insufficient knowledge on the ballistic coefficient of these spacecraft and the values of atmospheric density make the effects of aerodynamic drag an area that still remains uncertain. Correction algorithms are being researched in order to gain information to combat this issue through a combination of direct measurements and results from modeling processes. Electric propulsion is also used on satellites for transfer from high elliptical to geostationary orbit. The figure shown below showcases these types of orbits as a reference. This transfer is done using a combined scheme of high torque and low torque thrusters. Low torque electric propulsion systems operating on charged particles of propellant, which are accelerated in electrostatic or electromagnetic fields, ensure better fuel economy in comparison with powerful chemical thrusters. The downside to this is that low torque operation in strong gravitational fields may take weeks or months at a time. Thus, a combination of the two methods of propulsion is necessary. A chemical acceleration module is used on the last stage of the launch vehicle to form an immediate elliptical orbit, where then an electric propulsion system is utilized to adjust the orbit to the target parameters. In this scenario, we see chemical propulsion doing the heavy lifting in a way, with electrical propulsion being used at the end for fine tuning, thus allowing this transfer to be more efficient than it would be with just chemical propulsion. Now I'll go into the next area that hybrid electric propulsion is seen, which is general aviation field. Concepts for hybrid electric and pure electric aircraft have been developed so far for both the small private aircraft industry as well as the large commercial sector of the aviation world. The application of these technologies into the general aviation industry has been done for two main reasons: fuel economy and the reduction of noise. The noise level near airports is an area of concern that is continuously talked about today, and electric propulsion can be used as a way to solve this. Electrical motors are much quieter than internal combustion engines, and the conversion efficiency of electric motors is much higher than that of combustion engines as well. It is to be noted, however, that the implementation of this technology into the general aviation industry is in its very early stages. There is a substantial investment necessary from aircraft owners in order to design or build aircraft with these new technologies. It can be suggested that emerging technology in this sector comes with more risk than it does in another area. In comparison to a technology such as space, risks of travel and the effects to everyday life are more seen and have more effect on an everyday person and their decisions in general aviation than in spacecraft. The plane showcased here is an example of an electrically propelled passenger plane concept from Empirical Systems Aerospace. The final area I'll talk about in terms of the application of electrical propulsion is unmanned aerial vehicles. UAVs have begun to utilize these types of technologies because of weight reduction requirements and environmental protection issues that have developed. Current UAVs that have adopted electric technology have small electrical motors that allow them to operate across ranges in the order of magnitude of tens of minutes. These types of UAVs can operate using only a battery pack that can meet all the necessary power requirements. Current research in this area has focused on improving the endurance of unmanned aircraft with this technology while further enhancing their energy efficiency. The strategy going forward for hybrid electric systems is to implement a power regulator that can control the distribution of a variety of power sources in a way that allows them to operate more reliably and more energy efficiently. I hope this presentation has showcased how electric propulsion technology has been applied across a wide variety of areas and where it is going, as well as how it is being refined going forward. I'm not able to answer any questions in person, so I provided my email here in case anybody wanted to send me anything or post anything on the Carmen discussion board as you wish. This final slide continues references that were used for this project, and I appreciate you guys for all listening.